Hello, geometry students. Here's lesson 222. We're now moving into kind of the second section of chapter 2, which we're going to start talking about area for a couple of sections. And today you can kind of take a look that we are going to be talking about area of triangles and then also what are called composite shapes. Okay, and that's going to be, remember we've talked about that triangles are pretty much the basis of everything. So that's why we're starting with triangles. Okay, so if you notice, how much grass would it take to cover a football field? How much paint would it take to cover a stop sign or a room or whatever it might be? How many sequins does it take to cover a dress? So finding the area of different types of shapes enables us to answer many questions. So these are all different examples of where you would use area in real life. When you're painting something, when you're tiling a floor, when you go through and again covering a football field with grass or fertilizer or any of that kind of stuff. However, different people see shapes differently. So this is a big one for this chapter. Therefore, during this lesson, be especially careful to look for different strategies to use. And that's something we're going to talk about. So if you take a look in problem 270, this is all about different strategies to find areas. Okay, and so what I want you to do is I want you to do these problems and try to find the area of these 6 different shapes. You can go through and kind of sketch them. I want you to kind of show your work of how you get the area of all these different shapes. Some of them are nice, some of them are not so nice. In part B here, I want you to find the area of just the shaded part. Same thing in part E, just the area of the shaded triangle. Okay. Otherwise, everything else, I want you to find the area of like this L shape here. This one's a kind of an algebraic rectangle. We'll see if you remember how to do that. And then we will go over those questions in class. This will be kind of where we start to see what you come up with. Because like I said, the whole point of this problem is to be able to see how you did it, how you got these answers versus how somebody else got them. So we will discuss this. I'll have people share out the different ways that they did. So go ahead and do that. Pause the video. Go ahead and do all of those and bring these to class. Okay? All right, then let's go ahead and take a look at the next part. So Ishmael claimed that he did not need to calculate the area for part F in problem 270 because it must be the same as the area in triangle for part E. Is he correct? How do you know? Okay, and so I'm going to go back and take a look at that one. And not that I'm going to actually go through and probably find this specifically, and who knows, maybe I will. We'll take a look. But the idea here is what I want you to notice in this problem is notice that this triangle is half of this rectangle. Okay, so this rectangle has a base right here of 14 yards and has a height of 5 yards. Okay, well, if you come over here to part F, notice that the base of this triangle is 14 and the height is 5. So we actually have the exact same dimensions, a base of 14 and a height of 5. In problem E, though, we're looking at a rectangle and how a triangle is half of it. In problem F, it's just a straightforward triangle. But here's where we're headed. Here's what we're talking about. Is a triangle is, you can always draw a triangle and have it to be half of a rectangle. So if I went through and in part E, I found the area of this whole rectangle, 14 by 5, we would go through and get an answer. 14 times 5 is 70, and then I could cut it in half because I only want half of that. So this area for this triangle is actually 35 square yards. Okay? Squared units, because remember we're multiplying yards by yards. Whereas we come over here, and now let's say I try to use the same idea. I can go through, and if I go through and actually I can turn this triangle right here into a rectangle. And if you notice now, I've got a 4 by 5 rectangle that I can find half of. Well, 4 times 5 is 20. Half of that means that this triangle right here has an area of 10 square inches. That's what those 2 dashes mean, by the way. Those are units for inches. Then if I do the same thing on the other side, I can turn that into a rectangle as well and find half of that. Okay, if we take a look. So I've got dimensions of 5 by 10, so a total area of 50, but when I cut that in half, that means this triangle is 25, and now if you notice, 10 plus 25 gives me the same answer of 35. This one, however, is square inches instead of square yards. Okay? So same exact idea. We took one giant rectangle and then took half of it to get the area. Here I used 2 rectangles and took half of it to get the area. Okay, so that's kind of what Ishmael is talking about, that a triangle always has half the area of some corresponding rectangle. And so if you notice right here, let me go through and let me grab a highlighter. This is, you probably already knew this, but what we are doing is the area of any triangle must be 1/2 your base times your height. Okay, base times height gives you an area of a rectangle, and then we can always take half of it to get our area of a triangle. So we're going to add that to our toolkit as we start working our way through it. Matter of fact, if you want to add that, you may go ahead and do that. That the area of a triangle is 1/2 your base times your height. Okay? If we then continue, into the next part, now what we are looking at is we're trying to figure out how we can show that these triangles are all half of rectangles. Okay, so this one again in figure A, pretty obvious. That's exactly what we were talking about in that problem. There's my base. There's my height right there. I could find the area of the entire rectangle, divide by 2, multiply by 1/2. Either way, you get your answer. In figure B, notice they drew in the rectangle that's kind of on the outside, and really what's going on is right here. I can cut this right here so that here's one rectangle that I have a triangle that's half of that, and then on the other side, here's the other rectangle that has in it half of the area is half of that. And if I'm taking half of both parts, then it's going to end up being half of the total rectangle if I put it all together. Figure C, if we take a look, I could go through. Here would be rectangle number 1 right here. Cut that in half. There's your first rectangle. And then we would have rectangle number 2 right here. Okay, so this triangle, if you notice, is half of this giant rectangle. Okay, so there's our 1/2 base times height. And then figure D is a little bit trickier, because now when we're going to cut this in, we're going to drop this straight down. There's actually the height right there. It's actually outside of the triangle. And if I go through, here's where I can kind of work my way through this. Oops, that's not what I wanted. Get rid of that. There we go. And so here's kind of your giant rectangle that we have right there. And again, we have 1/2 base times height. This right here, though, the reason I wanted to show you this is notice that this is the height of our rectangle, which means that this right here is the height of the triangle. It happens to be outside of the triangle, and the base would still be that length right here. This would be the base of your triangle. This part would be the height of your triangle. Okay? So that should hopefully at least give you an idea of what we're looking at. That's the trickiest one for sure, when you end up with a height of a triangle on the outside. So then if we keep going, now what we're trying to do in this problem is we're trying to go through and have you find the area using our triangle formula now, 1/2 base times height, and identify what parts in each triangle you actually have, okay? Which ones you use to find the area. So one other thing that we didn't talk about is, how do you know which one's the base and the height? The base is always perpendicular to the height. There should always be a 90-degree angle. So as we go through and we take a look at this, in this first problem, notice here's my 90-degree angle, which means that 3 millimeters is my height, which therefore makes this 14 my base. Those are the 2 dimensions that we're using in this problem. The 5 millimeters is actually just some extra information. So if I wanted to find the area of that, I would take my base of 14, multiply it by my height of 3, and then I can divide by 2 in the end. This one should have an area of 21 square millimeters. Don't forget the units. That's one of the focuses of this chapter. Okay. In number 2 here, as we take a look, which one's your base, which one's your height? There's a lot of numbers going on. So again, if you notice, you just follow the right angle. This is the height of your triangle then. It's kind of like it's turned on its side, which makes this the base of your triangle. Those 2 are perpendicular. They intersect at a right angle. base and height of any shape are always perpendicular. So same thing again, those are the two dimensions that I'm going to go ahead and use to find the area of that triangle. My base of 5.9 times my height of 6.8. I will then divide that by 2 or multiply by a half, and I find out that this has an area of 20.06 square inches. Don't forget the units again. Okay? And then finally, this last one, this was our tricky one. If you go through and you're trying to find the height and the base of this one, notice here's our 90-degree angle right here. That means, like we were talking about on the previous slide, this is actually the height of that triangle. The base, however, is only this 6. Okay, so those are your two dimensions. It is 5 meters tall and with a base of 6 meters. So those are the two dimensions we're going to use. The 2 and the 9 are just extra stuff that you don't necessarily need. There's other ways to do this, but those are the dimensions that I'm going to use to try to narrow this down. So my base of 6 times my height of 5 gives me 30. Divide that by 2, and I end up with a total area of 15 square meters. And there's our problem for that one. Okay? So that's what we're looking at, identifying our base and our height, always perpendicular in different problems. So now if we come down here to part C, if you notice, we have Mario, Raquel, and Jocelyn are arguing about where the height is for this triangle at the right. The three have written their names along the part where they think it should be. Which person is correct? So first of all, what I'm going to take a look at is right away, I'm going to eliminate Raquel because Raquel doesn't even have, it's not perpendicular. Her side length is not perpendicular to anything, okay? So there's no 90-degree angle. She is automatically out, okay? So now it comes down to either Mario or Jocelyn. And what we have is when you draw a height in, it should go from a vertex of a triangle, meaning one of the corner points, it should start at a vertex and be perpendicular to the other side. So if you notice, let's take a look at Mario. His starts at a vertex, but if you notice his height right here, it is not perpendicular to that opposite side. Okay, so he's got this mixed up. He's actually got it perpendicular to the vertex, which is not what we want. So that one we're going to eliminate as well. Jocelyn is the one that we're taking a look at. Okay, so if you take a look at hers, I'm going to throw another color in here. There's her height right here, which is perpendicular to this extended side right here. Okay, if you extended that out, there's your height and your base for this problem. Okay, so Jocelyn is the person in this problem who's actually correct in drawing the height in. Okay, so hopefully that makes some sense. If not, ask about that in class and we can go over that a little bit more. Okay, then if we keep going, that's the end of the lesson. The last thing I threw in here was the math notes box. If I go back just for a second, all the way back to the beginning, if you couldn't remember how to find the area, remember we're taking base times height in this problem. Okay, so what you should have done is you should have multiplied this x plus 4 times the 2x plus 3 to get an algebraic area. Okay, you don't actually get an answer. You don't get like 15 or something like that. You should get an algebraic expression. Well, if you can't remember how to multiply 2x plus 3 by x plus 4 from Algebra 1, that's where this math notes box comes into play. Here's the idea of how you multiply binomials. Okay, we did a little bit of this in one of the practice to learns, but take a look at that. We'll go over it if we need to and discuss. Okay. Otherwise, your practice to learn is problems 274 to 278. Do the best you can. Try to get all that stuff taken care of, and come with questions if you have anything about any of the next parts. Okay. Good luck, and hopefully we'll see you in class and go over anything you need. Okay. Talk to you later.